I am Mr. True. In this video, we are going to once again continue our discussion of factoring polynomials. Specifically, we're going to be doing quadratic trinomials in this video, where we have a quadratic equation that means it has a degree of 2, or its highest exponent is 2. And in this specific video, we're just going to pay attention to the leading coefficients that are equal to 1. That really simplifies these problems. In the next video, we'll do it where our leading coefficient is something greater than 1, or just simply not equal to 1. So when you're factoring polynomials, when you're factoring trinomials that have a degree of 2, and the leading coefficient is equal to 1, you want to look at the patterns of the signs. If the constant has a positive sign, then you're going to be looking for factors of the constant that add to the middle term of b. And if you do that, you'll automatically get these signs correct anyway, but let me just point it out to you. If your middle sign is positive and your constant is positive, when you get your trinomial in factored form, if it indeed even factors, then you're going to have two positives inside your two factors. And because these are going to factors into two, this trinomial is going to factor into two binomials. If you have x squared minus bx plus c, then you're going to, of course, to get that constant, which is positive, when you distribute these binomials together, when you check your work, you need to be multiplying numbers that have the same sign. So now they're both going to be negative when your middle term has a negative sign in front. So constant is positive, your factors are going to or should have the same sign, and they're going to match whatever the middle term's sign is. Now, if your constant is negative, your constant is simply the term with no variable in it, just a number. If your constant is negative, then when you, I hate to say FOIL, but when you FOIL together those binomials or distribute together those binomials, the constants, which are going to be, well, they don't, I guess in harder problems they don't have to be constants, but when you multiply whatever your second term is in each binomial together, they need to have a different sign so that you get that negative constant at the end of your trinomial. We are going to have some examples where the last term really isn't a constant. They're kind of more advanced problems. You want those to have different signs in each of your factors. And we will be saying that factors of the constant, that you're going to be looking for factors of the constant that subtract to the middle term of b. Now, you can also add a negative, so really I could be saying that for when you're factoring quadratic trinomials, that you're always looking for factors of c that add to the middle term. If you're saying like there's a plus negative, but plus negative is the same as subtraction, so your teacher might be using slightly different language. I might even vary my language a little bit from these notes, but it's a nice sort of framework of what you're going to be doing. So we have x squared plus 2x minus 15. We do have a constant in that last term, so a very standard problem. And this is factorable with the leading coefficient of equal to 1. It is factorable if there are factors of 15 that subtract to give you a value of 2. Or, adding a negative that comes out to be a middle term of 2, or that coefficient. So what are your factors of 15? Well, your factors of negative 15 are going to be 1 and negative 15, but those subtract to be negative 14. If I reverse those signs, I'm going to get positive 14, and my middle term has a 2 in it, so I don't want that. Another set of factors for negative 15 are 3 and negative 5. Now, 3 minus 5 is equal to negative 2, and my middle term is positive 2. So I don't want the 5 to be negative, I want the 3 to be negative. And, this is just academic here. Negative 3 times 5 is, of course, negative 15, and negative 3 plus 5 is equal to 2. So there I'm saying the negative with the plus, but you're sort of adding in a positive and negative number, so you're, it's language, whatever, right? So you need a negative 3 and a positive 5. Those come together when you add them or subtract, add the negative, subtract, whatever you want to say. Negative 3 and 5 comes out to be 2. That's, of course, you're multiplying, and then it's negative 15. So that means that we're going to factor this like this. We're going to have a couple sets of parentheses and factors of your first term go in the first two blanks, and factors of your constant go in the last two blanks, if you will, of your binomials. And the factors of x squared, we're just going to square root that first term. As far as the variable is concerned, so we're going to have x and x. Really what I'm doing as well is I'm looking for factors of 1, which is just 1 and 1. We'll do some more advanced problems in the next video. And then factors of 15, well, the ones that we want are -3 and 5. Now, you really want to make sure that you check these answers. It's very easy to get a sign error with these problems. So I'm going to go ahead and let's see what color I might use it. We'll do our check in green. So let's distribute this together. So x times x is x squared. X times +5 is 5x. -3 times x is -3x. And then -3 times 5 is -15. Well, look at this middle term. Really, unless you've really messed up, that's the only place you really need to worry about checking. We have the x squared, we have the -15, and +5x minus 3x does indeed equal to 2x. So this was our correct answer. Got lots of lines all over the place now. X squared minus 10x plus 21, another very straightforward problem. The last term is just a constant. It's just now my last term, my last constant, or my constant is positive as opposed to being negative. So, and do note, by the way, negative constant, we needed those different signs. Now we're going to find factors of 21. Now, factors of 21 are, we have 1 and 21. We have 3 and 7, and that's pretty much it. Now, I'm writing all positive numbers, and, when I said my constant was positive, we need a set of factors, and they also need to add to that middle term. Well, I can't add two positive numbers and get a -10. I have the 10, but it's negative. Well, to do multiplication and get a positive number, you need to have those two numbers, those two factors, to have the same sign. So I don't really need +3 and +7. I'm not thinking of the answer I want to go to. I need that 3 to be negative, and I need that 7 to be negative. That's still +21. And then when I add them or subtract the negative, whatever, -3 and -7 comes out to be -10, which is our middle term, at least the coefficient. So let's go ahead and get that in factored form. Factors of your first term go in your first two blanks. Factors of your last term go in your last two blanks. And we have factors of 1 or 1 and 1, so we have 1x and 1x. The factors of 21 that we need is -3 and -7. And again, if you want to make sure that that answer is right before you have your teacher grade your work, distribute it together and make sure that it equals the original problem. Now, I've got 3 more examples. They start to get trickier. I've got 2 examples where my last term is not just a constant. And then I've got another one where we have, well, higher degrees. We're going to do a 4th degree and see what happens with that. Pipe! Keep on watching. For our next 2 examples, we're getting a little bit more complicated. We again have a trinomial here, but you'll notice that there's a variable in the first term and in the third term, which is, well, different as far as the examples I've done. But before we've had that x squared term in the first, x squared in the first term, and then we showed up with a square root of x, or just a single x, or x to the first degree, in the middle term. Well, now we have a y squared in the last term, and the square root of y squared is y, and we do see that in the middle term as well. So the fact that this last term has a y in it is not really a problem. It's y squared, and the square root of y squared is y, and we see that in the middle term, just like we've been seeing with the x. So we're just going to let that look like this. The square root of x squared is x. So we're going to see that in the first 2 blanks, or the first 2 terms of each of the binomials here that we have in our factors. The square root of y is y squared is y. And then we're just going to continue factoring like I did with all the other problems. What factors of 24, this is a positive now again, so what factors of 24 add to be 14? Well, we have 1 and 24, 2 and 12, we have 3 and 8, 4 and 6. The pair of factors that add to the middle term of 14, or the middle coefficient, or b, of 14 is going to be 2, and 12. And then if it bothers you that that last term has a y in it, and you're not really sure if this is right, of course, again, we can distribute this back together and make sure that we actually get that middle term that we were looking for. X times x is x squared. X times 12y is positive 12, got the 1 there, positive 12xy. And then 2y times x is positive 2xy. And then finally 2y times 12y is 2 times 12 is, there's the 24 that we needed. And we have y times y, which is y squared. Well, look, there is 12xy and 2xy, and the last time I checked, that does add up to be 14. Now, the last example, not the last example of the video, but I have up here, is 3x cubed minus 24x squared minus 99x. This is not a quadratic, and that's what I said we were factoring. However, again, first step of factoring is to see if you can find a GCF, a greatest common factor that you can pull out of all of the terms in whatever function or expression you're being asked to factor. And each of these terms have a factor of 3. That alone is not really an issue, except I haven't done leading coefficients not equal to 1 in this video. It's that x cubed, but they all do have an x. And we can take out the lowest exponent, the lowest number of x's that are in one of the terms, and that is x to the first power. So we're going to take a 3x out of these 3 terms. I'm not going to show the division like I did when we did the video factoring a monomial, but 3 divided by 3 is 1. Don't really need to write that if you don't want to. We're factoring an x out of each of these terms, so if we have 3 x's here and we're taking one of them out, we're left with x squared. 24 divided by 3 is 8, so minus 8x because there's x squared and we're taking one of those out. And then finally 99 divided by 3 is 33. And the only x that's in this term I've now taken or pulled out or undistributed or divided out with our 3x. Now we can factor, x squared minus 8x minus 33. And 33 is a little bit of a large number, but hopefully you're not that bad at doing mental math. Some of my students are that are too dependent on their calculators. We want factors of 33 that subtract to give you negative 8. Well, this last term is positive, negative. That means one of my factors needs to be positive, one of my factors needs to be negative, and we're going to be looking for negative 11 times positive 3. Negative 11 times positive 3 is negative 33, and negative 11 plus 3 is equal to negative 8, that middle coefficient that we need to match up with. So in factored form we have factors of the first term go in your first 2 blanks, which are going to be x and x. And the factors of 33, negative 33 that we want is negative 11 times, and positive 3. And that is that example in factored form. I got just one more example and we're going to be done with this video. So my last example is x to the 4th minus x squared minus 12. Now, this looks different than all the other problems because it's not a quadratic, again, like the title of the section says. It's x to the 4th. So is that really an issue? Well, I'm going to factor it in this format, but I'm going to temporarily say, let's let u equal x squared. So, I don't see any x, I see an x squared here, but I'm going to rewrite this a little bit and write this x to the 4th as x squared raised to the 2nd power. Is that the same thing? When we have stacked exponents, we're supposed to multiply those. That's a power rule for, or power property of exponents. And x squared to the 2nd power is x to the 4th. Minus, x squared minus 12. Now if I just temporarily let this other variable represent x squared, we have u squared minus, x squared I'm going to temporarily let equal u, which is going to be u minus 12. So By doing this temporary substitution of letting mu equal x squared, I can rewrite the equation, or the expression, excuse me, there's no equal sign. I can rewrite the expression to appear to be, or be in that quadratic form, which is what we're factoring at the moment. And then, factors of 12 that subtract to be -1 are -4 and +3. So we can write this as u minus 4 times u plus 3. And then remember that, u was not in our original problem. It was x to the 4th. It had variables of x's. X to the 4th minus x squared minus 12. And I let u equal x squared to, rewrite the question to make it look a little bit simpler. I can take that x squared now and plug it back in. And get to this problem. Now this may or may not be in your textbooks, I'm not sure. And I'm showing this substitution of u to make the question look different so that you can see that we're still factoring a quadratic. I would like to show you what this looks like without doing this substitution before I finish this lesson. It's not really just a video, right? I'm trying to make lessons here. I'm just not out dancing around. Okay, anyway. Don't want to see my bad dancing. Another reason or way you can identify that this is factorable or that this is still okay as far as this quadratic type setting is the first degree is 4. If you take 4 and you divide it by 2, that's what square rooting does to an exponent, you get a degree of 2. 4 divided by 2 is 2. And if you take that once again away, you just get your constant at the end, where your degree you have an original degree in your first term, you take that and you reduce it by a half, and then it just completely disappears. So if it were like 4,2 and the variable is gone, or if it was 6,3 and the variable was gone and it was a constant at the end, or 10,5 and then no variable in the last term, then you're still fitting that quadratic pattern that you can use and just factor whatever your problem is. And you'll see that here. We have a degree of 2 and here we have a degree of 1. Well, half of 2 is 1. So I'm just trying to talk you through many ways of seeing how this is still going to follow this pattern. Now, I'm just going to write the answer. The square root of x to the 4th is x squared. The factors of 12, we got a lot of them. We have 1 and 12, 2 and 6, 3 and 4. But the factors that subtract to be -1 and give you a middle value of -1 and a +1 is when was when 4 is negative and the 3 is positive, which is the same answer I got here doing that temporary substitution of letting u equal x squared. Well, that's how you factor polynomials, quadratic polynomials. Actually, let's just call them trinomials. These all had 3 terms. When the leading coefficient is equal to 1. What if it's a number that is not equal to 1? That's coming up in the next video. But for now, go do your homework.